project titled Deep Facial Diagnosis Deep Transfer Learning from Face Recognition to Facial Diagnosis. Nowadays, facial diagnosis refers to that practitioners perform disease diagnosis by observing facial features. The shortcoming of facial diagnosis is that for getting high accuracy, facial diagnosis requires doctors to have a large amount of practical experiences. Modern medical researchers indicates that indeed many diseases will express corresponding specific features on human faces. Nowadays, it is still difficult for people to take a medical examination in many rural and underdeveloped areas because of the limited medical resources, which leads to the delay in the treatment in many cases. Even in the metropolises, limitations including the high cost, long queuing time in the hospital and the doctor-patient contradiction, which leads to the medical disputes still exist. The main objective of this problem statement is to use disease-specific face dataset to predict 4 types of diseases such as beta thalassemia, Down syndrome, hyperthyroidism and also leprosy by using VGG16 classifier to predict the disease from faces. Hardware requirements: we need operating system, Windows only, processor, i5 and above, RAM should be 4 GB and above, hard disk should be 20 GB and above. Coming to the software requirements, we need to install Python with the version of 3.7. Methodologies: to implement this project, we have designed few modules. First one, upload facial diagnosis dataset. By this model, we will be uploading the dataset of the facial diagnosis to this application. Then second one, pre-processing dataset. By this module, we are going to read the images and then resize all the images to convert into VGG16 compatible format. And third one, fine-tune VGG16 transfer learning. By this module, we are going to train the dataset with the 80% of complete dataset and test the dataset with 20% of complete dataset to the VGG16 transfer learning model and predict the accuracy. Fourth module, accuracy and loss graph. In this module, we are going to plot the accuracy and loss graph of VGG16 transfer learning model. Fifth module, upload test image and predict disease. By this module, we are going to upload the test image of the dataset and predict the diseases based upon the VGG16 algorithm. Execution. Now, close this file and open the code file. This is the code file, consists of dataset file which contains train and test files, and next one, this is the model file which contains both pickle file and .h5 files. Pickle file is nothing but a serialized data format in Python used for a object serialization. It allows you to save the Python objects in a file and later load them back into the memory. Then .h5 file contains algorithm information which can be loaded into the project code during the runtime to utilize the trained model for various tasks such as making prediction on new data or performing specific operations. Then coming to the next folder, that is test images. These are used to test the model which is used in VGG16 learning model. The next one, this is the main code file and this is the runbat file. Runbat file, instead of executing the program in command line interface, we created Windows bat file to execute the project. So by clicking double tap on this folder, we will be leading into the graphical user interface which is used to interact with the program to the user. So you can see the graphical user interface now, and the first button, that is upload facial diagnosis dataset. By clicking this button, you can lead into the dialog box that contains of dataset. So select this complete folder and select the folder. Now you can see the dataset was completely loaded. And next one, pre-processing dataset. By clicking this button, you can see the pre-processing and reading and resizing the dataset images, and you can see the pre-processing of the classes which are had in 4 types, that are beta thalassemia which was indicated as 0, Down syndrome which was indicated as 1, hyperthyroidism which was indicated as 2, and leprosy which is going to indicate as 3. So next button, that is fine-tune VGG16 transfer learning algorithm. So by clicking this button, it will be training the algorithm and testing with the accuracy levels. And next button, accuracy and loss graph of VGG16 model. So by clicking this button, we can see the plot graphical representation of VGG16 transfer learning accuracy and loss. In the x-axis, you can see the number of approaches, and in the y-axis, you can see the accuracy levels. So you can see the green line that indicates the accuracy, which will be increasing the accuracy level by increasing the approaches. You can see the red line, which indicates the loss graph, which is decreasing by the increase in the approaches. So you can close this graph and go to the next button, that is upload test image and predict disease. By clicking this button, you can see the dialog box open and select the different types of images, which indicates the different types of diseases. So select one image and click on open. So it will indicate, the algorithm will indicate that beta thalassemia disease is found there. So you can text with the other data by clicking this button again, and you can select the other image. So you can see here the other diseases was detected, that is leprosy. Now close this file and click the exit button and close the entire process of the coding part. Now go to the conclusion. In this experiment result, the BGG16 algorithm was predicted with the best accuracy and appropriate deep transfer learning method in case of small data set of the facial diagnosis. Here we have dealt with the deep transfer learning from recognition of face recognition method to realize computer-aided facial diagnosis definitely and validated them on single disease and various diseases with a healthy control. Thank you.
Thank you for watching video. For more projects please visit our website www.trueprojects.in. For updates on latest project videos, please visit True Projects YouTube channel and subscribe.